We are moving into a section now called Euclidean geometry. So from grade 10 to 12, we've got two sections of geometry. We've got analytical and Euclidean geometry. Now this is the one discovered and pioneered by a famous mathematician known as Euclid. And this is the one we've already been looking at since grade 8 and 9. But the thing is, if you don't have a good foundation of grade 8 and 9, you struggle to do the grade 10, 11, and 12 work. And so the Department of Education has put a nice recap section into our syllabus to make sure that we are ready to tackle this section of Euclidean geometry. So let's have a look at some of the theorems and concepts that we should know very well by now. The first group that I want to look at is the group of lines and angles. Okay, so when we are dealing with straight lines, then we know that certain things are always going to be true regarding the angles. Okay, so the first one should look very familiar to you. Here we've got angle B, 1, 2, and 3. And if we are asked to determine the size of this angle here, this missing x, we can use the fact that two angles that are next to each other like this on a straight line, so we can see the straight line there, those angles add up to 180 degrees. And remember, we always set our work out in statement and reason format. So we can tell whoever's marking our paper that angle B2 plus angle B3 will equal 180, and the reason there is angles on a straight line. Okay, and we need to make sure that we get the right wording in these reasons because they are quite strict. Okay, you don't have to do this first step calling it B. You could actually jump straight in and say 139 plus x equals 180, and then you just need to solve that. So x is equal to 41 degrees. There we go. Okay, next up we've got angles here that are not quite, here's a straight line, but it ends there, there's a straight line, there's a straight line. But if you look, these angles here are all centering around this point B. Okay, be careful. This one is not called revolution. I've seen a lot of students lose marks there. This is called angles around a point. So if we add these together, we should get 360 degrees. So I'm going to say that this one plus this one plus this one, they are all angles around a point. Let's write that down. So angle B1 plus angle B2 plus angle B3. Remember this little hat on top of my letter signifies angle. Those add up to 360. The reason, be careful here, angles around a point. Okay, and now we can substitute. So B1, that's the x we want to work out. B2 is 110. B3 is 145. And together they must add up to 360. Okay, this is just a plain old equation. So we can take these to the other side and we'll be subtracting them there. So then x is going to equal 360 minus 110 minus 145. And that gives us an answer there of 105 degrees. Okay, angles around a point. Now, what I like to tell my students to do is to look out for an X shape. It's always so helpful when you know what to try and identify. So if ever you see lines that form an X shape, then that's quite helpful in solving things. So here we can see this X is unknown, and directly opposite, there's actually a given angle there of 78. And angles like this, I hope you can remember from grade 8 and 9, these are called vertically opposite angles. So they are across each other in this X shape. Okay, so then we can say angle B2 is equal to angle B4 because they are vertically opposite, so vert-op angles. Okay, and so that means that X is equal to 78 degrees. Alright, so these might seem very straightforward, but I encourage you to know them very well because they may pop up and you want to have easy access to them so that you can build your grade 10 geometry on these good foundations. Now the next section that you need to have a good foundation in is the section of parallel lines. Okay, and your teacher will have told you to look for letters like F, U, and N, and they will spell out fun. Let's quickly have a look. So F over here Those would make corresponding angles. A U could be formed between the two parallel lines and a line like that. Those would be co-interior angles. And then an N, that's going to be a bit tricky to see there because this drawing is sideways, but an N can also, I suppose, work like a Z, and those would be alternate angles. So let's take a moment to see how much of this you remember. Okay, so what I'm looking for here is X. I love to have a little highlighter with me when I'm doing geometry, and I'm given this 53-degree angle. Okay, and so if you quickly rotate your head all the way around, you'll see that is actually an upside down F. So there we formed corresponding angles, and corresponding angles are equal. Okay, so I can then say angle B4 is equal to angle Q4. Okay, and the reason is corresponding angles. And in order to get full marks for this, I need to mention the parallel lines. So AC is parallel to PR. So your reason is not finished if you don't tell the marker all of this information. Okay, and then we can say, well, now it's straightforward. X is equal to 53 degrees. All right, next up, we are looking for this angle Z, and we've been given this angle here. So I always like to build a bridge between what I want and what I've been given. Okay, that to me looks like an upside down U, and those are co-interior angles. Now be careful, co-interior angles are not equal, but we can add them together to get an answer of 180 degrees. So let's say here we're going to say angle B2 plus angle Q1 is equal to 180 degrees. And the reason, co-interior angles and the parallel lines, AC parallel to PR. Okay, and so that means that 60 degrees plus Z, the missing thing, is equal to 180. Let's move that 60 over, and so we find out that Z is equal to 120 degrees. Okay, and then last question on this slide here, we are looking for Y, there it is, and we have been given that 48 degrees there. So that's a nice zigzag. And what we know is that that means alternate angles. Okay, it's a sideways N over there if you want to look for fun. All right, so what do we know? We know those are equal. So angle Q4 is equal to angle B2, alternate angles, and the parallel lines. AC is parallel to PR. Okay, please don't miss out on any marks there. And so therefore, Y is equal to 48 degrees. Nice and straightforward there. Okay, corresponding looks like an F, co-interior looks like a U, and alternate looks like an N shape. And don't forget to list the parallel lines. Now let's solve some triangles. Okay, if ever you see this little shape here, know that that means 90 degrees. Okay, and in this triangle here, if I look at it, I'm looking for X, and I've been given 90 and 50. So I've got a full triangle here. And what do we know about the angles of a triangle? They add up. Angle A plus angle B plus angle C adds up to 180, and the reason is interior angles of a triangle. Okay, now I can substitute. A is X, X plus, B is 90, C is 50, and then we just need to solve. So 180 minus 90 minus 50, that'll be the answer there for X. So X is 40 degrees. Okay, next up, we are asked to find Y, and we are given this little angle here of 72. Okay, another thing that I'm hoping you are spotting is that this is an isosceles triangle. Okay, and we know something about the angles that occur opposite these equal sides, and that is that they are equal. So I can say angle F is equal to angle E, and then be careful here, this is a reason students often get wrong. The reason is angles opposite equal sides. Okay, so don't tell your teacher isosceles triangle, because even though it is, it is an isosceles triangle, but that's not the acceptable reason here. We need to say angles opposite equal sides. All right, so that means that y is equal to 72 degrees. And then lastly, this is the one that everyone always forgets about. We need to find angle Z, and we've been given this over here, H, and then this one outside of the triangle. Okay, now most of the time, my students will say, well, there are angles on a straight line, and then we have interior angles of a triangle, and that's not wrong. It's just quite long. Okay, so back in grade 8, we learnt a theorem that said the sum of the two interior opposite angles is equal to the exterior angle. Okay, so that means this exterior angle here is formed by two sides of my triangle. This exterior angle is equal to the sum, that means add, the interior opposite. So not this one, the opposite two. So let's set that up. Angle G plus angle H is equal to angle J2. And the reason there is exterior angle of a triangle. And now I can substitute in Z plus 75 degrees equals 105. And then let's take that 75 over, and we've got 105 minus 75. And so Z is equal to 30 degrees. All right, so interior angles add up to 180. When you are dealing with an isosceles triangle, then you've got angles opposite equal sides, and they are equal. And then if you're given an exterior angle, it is equal to the sum of the interior opposite angles. So this plus this. Let's have a look at an example where everything comes together. Okay, determine with reasons, they shouldn't even have to tell us that, we know, the size of angle ADC. All right, that should have a little hat there on the D. Let's figure out exactly where that angle is. So find point A, follow it up to D, and then up to C. So that's angle ADC there. It's D1 plus D2. And then later on, I'm guessing, angle E. Okay, so those are our unknowns. Let's go about figuring it out. Okay, so they've been kind enough to break this up into two angles for us. And so what I like to do is I like to link the information I want. So let's see what we can figure out about this if we link it to some of the information that we've been given. So there, just by drawing in that or by highlighting those, I see there's a triangle. And I know something about the interior angles of a triangle. Okay, so angle D1 plus angle C plus angle B is equal to 180 degrees. Interior angles of a triangle. Okay, so D1 plus 57 plus 72 equals 180. And then all I'm going to do is take those over and subtract them. And so I'll find that D1 is equal to, let's see, 180 minus 57 minus 72 gives me an answer of 51 degrees. And I like to, the minute I find it, pop it in there. Okay, so the question was to find this whole angle. I'm part of the way. I now need to look for something that can guide me to find this part of the angle. Okay, now another important thing here, which I'm seeing as I'm looking at it, is these lines are parallel. Okay, that's what those little triangles mean. Okay, so I can start to look maybe for something to do with these parallel lines. So let's see what happens if I follow. I'm seeing a Z over there, or a little N shape. Okay, so that means that and that is going to be equal, because those are what we call alternate angles. Okay, so let's have a look. D2, this is now the next step in the process, is equal to angle, they haven't numbered them, so I can number them 1 and 2, or I could call this DAE. It's entirely up to you what you prefer. Let's go with A2, it's nice and quick. All right, and the reason there is alternate angles. And don't forget to mention the parallel lines. BD is parallel to AE. Okay, and so that means angle D2 is equal to 27 degrees. All right, so we've got two bits of information. that now allow us to answer the question. So therefore, angle ADC is equal to 51 plus 27, and that gives us 78 degrees. All right, and then they said angle E. So let's see E. Now that I know that I've got these parallel lines here, I'm definitely looking out for something to do with that. So can I link it to its parallel line up here and have a look there? It's getting very colorful in the sketch, but I can see an upside down letter F there. Okay, so I've already figured out that 51 degrees. So now I can just build on that knowledge, and I can say angle E is equal to angle D1, corresponding angles, that's the one that goes with the F, corresponding angles, list the parallel lines, BD is parallel to AE, and so therefore angle E is equal to 51 degrees. And there you have it. So it's important to have all your foundations in place, and straight away, the minute you see parallel lines, you know what to look for. The minute you see triangles, you know what to look for.